Hello everyone, in this video we're gonna solve this exercise, which is a proposed exercise for the subject of theory of structures. As you can see, we have a frame with a punctual moment and a punctual force. It's important to remark that we have a hinge, elastic support, and a pin joint with an elastic support limiting the rotation. As data, we have the lengths of the beams, which are considered to be 1 meter, and as well we have the moments, the value of the moment, which is 5 kilonewtons per meter, and the value of the force, which is 10 kilonewtons. Well, first of all, we're going to start solving the reactions. In the support, in the vertical support, we're going to have only a vertical force limiting movement. I'm going to start calling the different points A, B, C, D, E, and F. So here, in this support, we're going to have a vertical reaction, which its name is going to be B. Well, we go to the other support, we're going to have a vertical as well as an horizontal reaction, and the effect of this spring, this circular spring, is going to give us also a moment reaction called MF. Well, now we have to solve the reactions. As you can see, we have 4 unknowns. The different equations for solving these reactions are the sum of the forces in the horizontal direction must be equal to 0, sum of the forces in the vertical direction equals to 0, and the sum of the moment in one of the points, the ones we want in the structure, to be 0. In our case, we're going to take the point F, as it is the one which contains more forces and unknowns. So you can say, well, we have three equations, but we have 4 unknowns. So here we have the hinge, which adds one equation more, which is the sum of the moments at the hinge must be equal to 0. We choose one side of the hinge, we calculate moments and equal that to 0. Well, we are gonna start now solving reactions. We start by the first equation. As horizontal force, we've got P plus HF, and those are the horizontal forces, sorry, equals to 0. Now, the vertical forces. We got reaction at B, which is in the upper, which goes up, so positive. And then we got BF, both of them equal to 0. Now we go to moments. We start by here. As I said before, we're going to calculate moments with respect to F. This moment is anti-clockwise, so it's going to be positive. Now, we calculate moments at these points, so this vertical force is going to create a moment which is going to be negative, as it will be clockwise, times 2L, which is the distance from this point to this point, which is going to create a moment. Now we continue. P is also going to create a moment, which is also going to be clockwise, so it's going to be negative. P times L, this distance. And now I have to add the value of MF, which is going to be positive, equals to 0. Finally, we got the equation of the hinge. In this case, we're going to take from the left part of the hinge. Well, we're gonna have a positive moment, M, and then this reaction is gonna create a clockwise moment, so it's gonna be negative times L equals to 0. From this equation, we can get the value of this reaction, so it's gonna be M over L, and in this case 5 kilonewtons meter over 1 meter, and it's 5 kilonewtons. Well, we have one reaction. We have to get the rest of them. Well, now we can go to equation 2. So BA, the vertical reaction at F is going to be minus the vertical reaction at B. So it's going to be minus 5 kilonewtons. Now, from equation 1, as P is known, we can get the value of the horizontal force. So it is going to be minus P, and it's going to be minus 10 kilonewtons. Well, finally, we go to equation 3, and the only unknown is MF. MF is going to be equal to minus M plus vertical reaction at P times 2L plus PL. And finally, MF is going to be minus 5 kilonewtons meter times plus 5 kilonewtons times 2 meters plus P times L, 10 kilonewtons times the length, 1 meter. So MF is going to be 15 kilonewtons per meter. So now we have all the reactions calculated. As follows, we're going to calculate the different diagrams. Well, we're going to start drawing our structure. We're going to start by the moment diagram. Well, now we put we have the moment, here we forgot force, P. Now here the value of the reactions. Here 5 kilonewtons. Here we find 5 kilonewtons. Here we have 15 kilonewtons per meter. Finally, here we got 10 kilo. We are just putting the values of the reactions previously calculated, so that they help us calculating the bending diagram. Well, this value is equal to 5 kilonewtons meter, and this is equal to 10 kilonewtons. Well, we are gonna start first reminding the way of calculating a bending diagram. In this case, we're gonna put the bending diagram in the upper part when the part of the beam under under tension is the upper part, and in the lower part when the part under tension is the lower part. At the beginning, we're gonna have an anti-clockwise moment, which is gonna cause a jump in the bending moment diagram, value 5 kilonewtons per meter. Well, now this value is gonna continue as there are no moments nor forces. At this point, we have a force. At the hinge, it's very important to know that the moment is gonna be 0. So the bending moment diagram is gonna have to pass through this point. As here we have a force, slope is gonna be negative, and it's gonna pass through this point until reaching 5 kilonewtons meter. In this part, the upper part of the beam is going to be under tension, and in this part, the lower part of the beam is going to be under tension. So the first part of the frame, we have the value of the bending diagram. Now we are going to start by this point to calculate this vertical part. Well, we have anti-clockwise bending moment. So there is going to be a jump of value 15 kilonewtons per meter. The force, this force, is going to generate a negative, so negative slope is going to reduce the bending moment diagram to this point, to a value of 5 kilonewtons per meter. And then it's going to continue constant as there are no other forces in its path till 5 kilonewtons meter. And this zone is going to be under the left hand side of the beam, is going to be under tension. So that's the bending moment diagram. Now we are going to continue with the shear force diagram. We draw as well the frame. Well, as you can see, in this part we've got no forces, so the diagram is going to be 0. Now here we're going to have a jump of value 5 kilonewtons. Then it's going to continue constant till here that we have a force of -5 going down. So it's going to be like this. Now we continue through the vertical beam. Through here we have no forces, so it's going to be 0. Well, that's clear that here is going to be 0. Now, following this support, here force 10 kilonewtons meter, keeps constant, then this force P make it go down to a value of 0, which coincides with the closes the diagram. This is 10 kilonewtons. So that's the shear force diagram. Finally, we have to perform the compression or tension, the axial force diagram, but in this case it's pretty simple. I'm just going to draw it over the shear force diagram. I'm going to call it N. Well, as you can see in the upper part, we've got no axial forces. They will only appear here. We have a force here of 5 kilonewtons in tension, and this also tension. So this part is going to be tensioned to 5 kilonewtons. This is 5 kilonewtons. Tension. Well, and that are all the diagrams. So we finish the video. See you. Bye.